Hello students, as in the last lecture we completed with the type number 1A, which was based on uh, this type integral 1 upon quadratic. As I told, for type number 1A there are three formulas. The first one, it was integration of 1 upon x square plus a square. Second one, that is 1 upon x square minus a square, and the third one is 1 upon a square minus x square. Now we'll see the type number 2A, which is in the form of 1 upon, the integral will be in this form, 1 upon root quadratic. Okay, like this, 1 upon, inside the root it will be the quadratic. Okay, so whenever you come across this integral form, so you have to apply this three formula. Okay, as clearly you can see that almost the formula, it is the left hand side, it is same only. The integral part of the left hand side will be same, just here it is without root and here it is inside the root. So 1 upon x square plus a square, here it is 1 upon root x square plus a square. Here it is 1 upon x square minus a square, here it is 1 upon root x square minus a square. Why this is inside the root? Because the question itself, it is inside the root, because the form is what, 1 upon root quadratic. So here the second last step will be in this form, 1 upon root x square plus a square, 1 upon root x square minus a square, and third formula will be 1 upon root a square minus x square. So the first formula is what, whenever the integral it is in this form, 1 upon root x square plus a square into dx, so the answer will be what, log mod x plus, can you see, x plus, can you see, this section is what, is the same question. So you can remember this formula as log mod x plus same question plus c. You can remember this formula as log mod x plus same question plus c. Second formula is 1 upon root x square minus a square into dx, log mod x plus, here also same, this part, the question will be there, this part. Okay, when you will solve, this part will come. Okay, so you can remember this formula, these two formulas, log mod x plus question, second formula is log mod x plus question plus c, like that. Okay, because whatever it is there, it is the same thing here, it is there, yes or no, x square plus a square root x square plus a square. So that's why I told you can remember this formula as log mod x plus the question, log mod x plus the question. The third formula, when you have to apply, whenever the symbol of x square is negative, whenever the symbol of x square is negative, okay, see to that you have to apply the third formula. So remember this, whenever the symbol of x square is negative, straight away you have to apply the third formula, same as which we had done in the type number 1a. Whenever the symbol of x square is negative, we have to apply the third formula. Here also same, whenever in a question itself it says that the symbol of x square is negative, straight away you have to apply the third formula. So third formula is what, sine inverse x upon a plus c. Okay, so this is the type number 1a, this is the type number 2a, and in the next lecture we'll see the type number, that is the type number 3a, and these are the sub type number 1b, type number 2b, and type number 3b. I hope you all understood the type number 1a. So let's begin with the uh, type number 2a. Let's take some few example based on type number 2a. Before that, we'll see the concept based on the type number 2a. Here also same, there are some steps which you have to follow, and the steps are same as the type number 1a. So the step number 1 will be what, make the coefficient of x square 1. Here can you see the integral, it is in the form of 1 upon root quadratic, yes or no? So here can you see the coefficient of x square is 1. So the first step it will be same which was there as in the type number 1a also. Make the coefficient of x square 1, symbol of x square should be positive. Yes. Okay. Step number 2, again same, you have to apply the third term formula, that is half into coefficient of x. So here you will get one number. Whatever the number you are getting here, in the step number 3 you will add that number to alphabet. Same step you have to follow. The change is what? The formula. That's it. Okay. Subtract the number to the number. Then that section will get converted into, either it will get converted to a plus b the whole square, or it will get converted into a minus b the whole square. I hope you all might be knowing how to apply step number 1, 2 and 3. And what is the step number 4? Simply you have to apply the suitable formula. Just you have to check for that particular question which formula we have to apply, first, second or third. Okay, the first formula when it will come, when in the first section you have alphabet and in the second section you have number. A is what? It is a number, and between the connection between these two it will be plus, so you will apply the first formula. When the connection between alphabet and number is minus, you will apply second formula. And see to that whenever in the question itself if the symbol of x square is negative, you have to apply the third formula. Whenever the symbol of x square in the question itself it is negative, see to that you have to apply the third formula. Whenever the symbol of x square is positive in the question, no doubt either the first formula will come or else second formula. In this way you have to guess the formula, you have to apply the suitable formula for the particular question. So now here we have the first example in front of you all. So integral 1 upon root x square plus 8x minus 20. So here clearly we can see that the coefficient of x square is 1 and the symbol of x square is positive. So now exactly what we have to do. Okay, now we'll start the presentation part here. So you will have this question. The first step, of course, you will write let. You will take I equals to integral 1 upon root x square plus 8x minus 20 into dx. Okay. After this, okay, make the coefficient of x square 1 and the symbol of x square should be positive. Already it is 1 and the symbol is positive. We'll move on to the second step. Second step is what? We have to apply the third term formula. So third term formula is what? Half into coefficient of x. Here the coefficient of x is what? Plus 8. So 2 ones are 2 fours are. 4 square is what? 16. So here we got that number. Yes or no? So now we'll make a pair of alphabet and number. As per the rule, as per this step number 3, we have to add that number to alphabet. We will add that number to alphabet. Yes or no? And subtract that number to number. That is the step number 3. Yes or no? Add that number to alphabet and subtract that number to number. I hope you all understood the step number 1, 2 and 3. What is the step number 1? Make the coefficient of x square 1. Already it was 1 and the symbol was positive. What is the step number 2? Apply the third term formula. So where you will get one number. So here we got 16. You will add that number to alphabet. Okay. Just in the previous step make the pair like this. So you will come to know that we have to add that number to alphabet and subtract that number to number. Okay. It is not compulsory that you have to make this pair like this. Okay. So now the next step is what? This part, this section, either it will get converted into a plus b the whole square or a minus b the whole square. As suppose the first term symbol and the second term symbol, okay, like here and here it is positive. So plus and plus. So of course that section it will get converted into a plus b the whole square. So this part we can write as a plus b the whole square. Okay, like how, see here, uh, square root of x is what? X. Here both are positive, so we'll write plus. Square root of 16 is what? 4 the whole square. Okay, so when you will apply a plus b the whole square here, a square plus 2ab plus b square. You will get this same previous step. So I wrote this step x square plus 8x plus 16. I reduced this step as I wrote this step as x plus 4 the whole square. So remember, for each and every sum for this type or type number 1a or type number 3a, see to it that after this step either this part will convert into a plus b the whole square or a minus b the whole square. It is very simple to guess. If both this section is positive, so a plus b the whole square will come. If first is minus and second is plus, so a minus b the whole square will come. Okay, so now here, as clearly we can see that minus 20 minus 16, it will be what, minus 36 into dx. Okay, now after this, as we all know that what exactly we have to do, as the first part it is in whole square form, so we have to write the number also in whole square form. So we know that 36 we can write as 6 the whole square, yes or no? So 36 we can write as 6 the whole square. 6 square is what, 36. You will get the previous step. It is very important step. Remember this, keep this step in your mind. If this part it is in whole square, so you have to write the second number, that means the second section, that is the number also in this form, the whole square form. Okay, after this step only you have to apply the suitable formula. Okay, now we'll guess the formula, which formula will come. As we know that there are three formulas. First we'll check, as this is what, 6 is number and x plus 4, this 4 is with x, so we'll consider this whole section as a number, whole section as alphabet, and 6 is a number, and here the connection is what, minus, so this is alphabet, and we'll consider this section as x and this section as a, so here the connection is minus. So here clearly we can see that this section, this integral look like the second formula, 1 upon root x square minus x a square. Can you see the first part is alphabet and the second part is number? So when the first section is alphabet, second section is number, and the connection is minus, so we'll apply the second formula. Second formula is what, log mod x plus the same part will come root x square minus a square plus c. So let's apply the suitable formula. So here the formula is what, 1 upon root x square minus a square into dx. Integration is what, log x plus root x square minus a square plus c. Okay, so here what we will be doing, we will be integrating with respect to x. So this integral section, it look like this part, so its answer will be what, log mod x plus root x square minus a square plus c. So the integration answer will be what, log mod x, what is there in place of x, it is x plus 4, yes or no, plus root x square, so this is x square on this part, yes or no, this is x square minus a square, so this is what, a square, that same part will come, yes or no, the same section will come here. So that only I wrote log mod x, as I told how to remember this, log mod x plus the same question will come, yes or no, the same question will come. So here it was x plus for the whole square minus 6 square, that only I wrote. Okay, after this a basic adjustment you have to do. What basic adjustment? This will write same as it is. Here you have to solve this section as this look like a plus b the whole square. Okay, basic algebraical basic things you have to do in the next step if you can. Okay, as here clearly we can see that this we can write as a square plus 2ab plus b square, so this can be written as what, a square plus 2ab, that means 8x plus 16 minus 6 square is what, 36. Okay, so in the next step I equals to log mod x plus 4 plus x square, okay, plus 8x plus 16 and minus 36 what, minus 20 plus c. After this I guess we cannot solve the sum further, as we know that this look like a quadratic. Okay, but don't solve the sum further, Don't apply any factorization method like splitting of middle term. Okay, after basic adjustment, after this step, after applying the formula a plus b the whole square, just see the like terms. Okay, solve this number and stop your answer. No need of solving the sum further, as this look like a quadratic, okay, form. So don't apply any factorization method like splitting of middle term. Again the third term method. Okay, third term method only we have to apply only one time. Okay, after the basic adjustment you have to stop your answer. So this was the presentation part for the first sum. I hope you all understood the first sum, how to apply the suitable formula, how to guess the formula, and how to solve the sum whenever the integral part it is in the form of 1 upon root quadratic. Okay, yes or no? So once again I will explain the sum. First step is what make the coefficient of x square 1. Already it was 1. The symbol of x square should be positive. Yes, already it was positive. Then after that apply the third term formula, so where you will get the number. So see to it that in this you will add that number to alphabet and subtract that number to number. After that, this section, this first part, it will get converted into, either it will get converted into a plus b the whole square or a minus b the whole square, as both the symbol is positive, so a plus b the whole square will come. Minus 36 in the next step will write as 6 square. It is very important for each and every sum. That's it. With that, whenever this section is in terms of whole square, so you have to convert this number into whole square also. Okay, so 36 we can write as 6 square. After this adjustment only you will apply the suitable formula, as clearly we can see that this formula it look like 1 upon integral 1 upon root x square minus a square, and which is equals to log mod x plus root x square minus a square. Apply the formula, just basic adjustment, and then stop your answer. I hope you all understood the first example. So let's take one more example. Okay, we'll take now one example where you will see, where you have the coefficient of x square, and we'll make the coefficient of x square when 1, and then after that we'll proceed the sum further. So let's move on to the example number 2. So here in the second example, as we clearly we can see that here we have integral 1 upon root 3x square plus 5x plus 7. Yes or no? So can I say here we have the coefficient of x square as 3, not 1. Okay, so let's begin with the sum now. As per the rule, we have to make the coefficient of x square 1, and the symbol of x square should be positive. The symbol of x square is positive. Now we have to make the coefficient of x square 1. Now listen here that 3 it is inside the root, it is not without root, as I had explained two method how to make the coefficient of x square 1 in the last lecture, when we were solving the type number 1a. So I had explained the two method how to make the coefficient of x square 1. So here we'll take the simplest method. Again same, first we'll write I. We'll start with let I. Okay, don't forget to write let square root 3x square plus 5x plus 7 into dx. Now here we'll see how to make the coefficient of x square 1. So simply what you will do, here you will remove 3 as common. So inside the bracket what you will get, x square plus, here this will be 5 upon 3x, and here it will be 7 upon 3. How, see, if we remove 3 as common, so from here 3 will come out. Here we don't have 3, so in denominator the 3 will go. Here also we don't have 3, so in the denominator the 3 will go. Okay, you can check whether this step is correct or not. Simply bracket open with this 3, you will get the previous step. If you are getting the previous step, then you can click that the steps what we had did, it is perfect. So just simply bracket open. So here you will get 3x square, yes or no? So when you will bracket open with this, so 3 will get cancelled, you will get 5x, 3 will get cancelled, you will get 7. Okay, so in this way you can make the coefficient of x square 1. So there is one more method, but as I told, I will explain the simplest method how to make the as in the type number 1a also. I had explained two different method in which you can make the coefficient of x square 1. Okay, yes or no? So with the simplest and the easy method I will go further. Okay, so here simply what you will do, you will remove common, as here we can see that 3 is the coefficient of x square, so remove 3 as a common. So inside the bracket you will get x square plus 5 upon x, 5 upon 3x plus 7 upon 3. Okay, when you will bracket open with this, you will get the previous step. If you are getting the previous step, then this step is perfect. Okay, now after this there is one simple concept. What is a simple concept? Suppose if there are two terms inside the root. Okay, suppose like a, and then suppose here it is x square. Okay, suppose this section it is without the integral, a basic adjustment I am showing now. It is without integral. Okay, 1 upon a basic step. Okay, a and x square. So can I write this step as, sorry, 1 upon, can I write this step as root a into root x square? Yes. Can I write this step as root a into root x square? Yes or no? Yes, we can write this step as root a into root x square, as here the order is same. When the order is same, we can multiply, so you will get this previous step. Like suppose if here we have a root 3 into x, so this can be written as 1 upon root 3 into root x. I hope you all understood this step. So here also same thing we will be going to do. So this in the next step we can write this step as clearly we can see that there are two sections. So root 3 into root x square plus 5 upon 3x plus 7 upon 3. I hope you all understood this step. So what exactly I did, suppose here we have one number and alphabet and both are inside the root, so this step can be written as root 3 into root x. Yes or no? Yes, we can do this step like this because here the orders, clearly we can see the order of both the terms is same. When the order is same, so we can multiply and you will get the previous step. Yes or no? I hope you all understood this step. After this, as clearly we can see that now after this step we can remove this 1 upon root 3, as clearly we can see that it is a number. As per the rule, whenever we have any constant inside the integral, okay, so we can write this k outside, we can remove the constant outside the integral. Yes or no? This was the rule. Whenever we have any constant inside the, constant means any number inside the integral, so we can remove that constant outside. Okay, as here clearly we can see that we have to make the coefficient of x square 1, so that's why we did this step. And as 1 upon root 3 we can see that it is a constant here, so we can remove this 1 upon root 3 outside the integral, and we can rewrite this step as like this. Yes or no? Okay, so in this way you have to make the coefficient of x square 1. Simple step. What exactly you have to do, see the coefficient of x square, remove that number outside, means make it as common. So here we'll remove 3, so inside the bracket you will get x square 5 upon 3x and 7 upon 3. When you will bracket open this step, you will get the previous step. If you are getting the previous step, that means this step is perfect. After this, we'll apply this basic concept, as when there are two terms inside the root, we can write this step as like this. So that only we did. So as per the rule, whenever we have any constant inside the integral, so we can remove the constant outside. Okay, so in this way you can make the coefficient of x square 1. So there are some few different method also. It's all depend on the teacher, as I told, how he or she will teach. Okay, So as I think this method is easy. Okay. Okay, so now after this, uh, make the coefficient of x square 1. So here I made the coefficient of x square 1. The symbol of x square should be positive. Yes, already the symbol of x square is positive here. So now the step number two is what we have to apply the third term formula. So what is the third term? We'll apply the formula, that is half into coefficient of x. So here clearly we can see that the coefficient of x is 5 by 3. Okay, we cannot cancel any number here, so we left with 5 upon 2 3 is 6, 5 upon 6 the whole square, so this will be 25 upon 36. So here we got that number. Okay, so here we'll make the pair like this. So in the next step what we'll do, okay, so we'll add this number to the alphabet. As per the rule, it says that in the step number 3 we have to add that number to alphabet. That only I did. And subtract that number to number. We'll subtract that number to number. I hope you all understood this step. Okay, so we have to add that number to alphabet and subtract that number to number. After this step, what we have to do, okay, focus here. As after this step, this section will get converted into a plus b the whole square or a minus b the whole square. As both the terms, both the symbol here it is positive, when both the section it is positive, so it will get converted into a plus b the whole square. Okay, so here x square root will be x plus, just simply you have to check the first and last term. No need of seeing the middle term. Okay, first term and last term, it's square root. So x square root will be x, 25 square root is what, 5, and 36 square root is 6, and it is in the form of x square plus 2ab plus b square. So we can write this as a plus b the whole square. Okay, now after this step, yeah, both the numbers are in fraction, so there are two different methods to solve the sum. Okay, either you can cross this number and you can solve the sum further, or else the simplest method is what, try to make the denominator same. Okay, so we'll, without, okay, making the denominator same, don't solve the sum further. So there are two method, one cross multiply or else make the denominator same. So the best and the simplest method will be what, to make the coefficient, to make the denominator same. So when you will cross multiply, what will happen, clearly we can see that this number will be bigger, 36 into 7, 3 into 25. Then after that you have to cancel, you have to reduce the number, and then you have to solve. So the simplest method here will be what, whenever you come across like this, whenever you have a fraction and the denominator is different, first make the denominator same. As to make the denominator same, here it is 3 and 36, so we'll multiply this 3 by 12. Yes or no? We'll multiply this 3 by 12. If you multiply this 3 by 12, you have to multiply the numerator also by 12. Yes or no? Okay, okay, so minus 25 upon 36. Okay, always applying this concept, make the denominator same instead of cross multiplying. Okay, so I equals to 1 upon root 3. So root x plus 5 upon 6 the whole square. As 7 12 it is 84 minus 25. Here clearly we can see that the denominator is same. So we'll write only one time. Okay. After this, I equals to 1 upon root 3 integral 1 upon root x plus 5 upon 6 the whole square. 84 minus 25 it is 59 upon 36 into dx. I equals to 1 upon root 3. As we know that if this section it is inside, if this section is like the whole square form, so we have to write this number also in whole square form. So 36 square root is 6, and 59 square root, I guess 59 square root is not there, so we can write this 59 as root 59 the whole square. Yes or no? If we don't have the square root of any number, so we have to write that number in a root form. Okay, suppose if we don't have the square root of 2, so in the next step, so we can write this 2 as root to the whole square. Suppose here it is 5, so we don't have the square root of 5, so we'll write the square root of 5 as square root of 5 the whole square. Remember this step, whenever we don't have a square root of any number, so we have to write inside the root. Okay, after this step you have to guess the formula. As clearly we can see that this is the number and this is what this 5 upon 6, it is with x, so we'll consider this whole section as x, and this is a, so this formula look like the first one. Yes or no? Integral 1 upon x square plus a square, the formula is log mod x plus root x square plus a square, so we'll apply the formula directly. Okay, so this 1 upon root 3 will be what? It will be same till the last step, as it is a constant over there. So as I had explained in the last lecture also, whenever we are getting any common outside the integral, constant, any constant outside the integral, you have to keep the constant till the last step as it is. Okay, now we'll apply the formula. So indirectly what we will be doing now in the next step, we will integrate with respect to x. So as we know that this section look like the first formula, so it says that log, this constant you will write same as it is, so you will write log mod x. What is there in place of x? It is x plus 5 by 6. Okay, then plus square root. Okay, the same part will come, x plus 5 upon 6 the whole square plus or root 59 upon 6 the whole square mod close plus c. Okay, then after that a basic adjustment you have to do here. When you will cross this step, so you will get 6x plus 5 upon 6 plus, yes, of course you have to solve this section as this is in the form of a plus b the whole square, as we did in the last sum also. So this section will be what? A square plus 2ab plus b square, so this will be 25 upon 36. Square root of 59 is 59 and square of 6 is 36 mod plus c. I equals to 1 upon root 3 log mod, so this part will be same, 6x plus 5 upon 6. Okay, this will be what? X square plus 2 ones are 2 threes are, so this will be 5x upon 3. As here clearly we can see that the denominator is same, 25 plus 59, it will be 84. Okay, you have to solve the sum further till the, if you feel that we cannot solve the sum further, like suppose here, of course we can cancel this number, we can reduce this number, so we can increase one more step here. If you feel that we can solve the sum further, then it is compulsory you have to solve the sum further without making any mistake. Okay, so this will be what? X square plus 5x upon 3, so this is common, this both the number will goes in 12 stable, 12 sevens are 12 threes are, so 7 upon 3. I hope after this we cannot solve any step further, so this is the last step. So in this way you have to present your sum whenever the coefficient of x square is not a 1. I hope you all understood the second sum also. Okay, so let's take some few example based on the type number 2a.